digital world. Difficult to follow a crisp presentation with the number of slides that I have, but I'll try to keep it as crisp as possible and as interesting as possible. For the past month and a half, there have been at least a couple of incidents across the world related to public safety. The first one in London, you had in the underground, there was an explosion, and just due to panic, there was a lot of issues. The second one, just about 10 days back in Las Vegas, there was a shooter who was holed up inside a hotel and started spraying bullets on a live concert that was taking place, killing a lot of people. Right? These are two public safety incidents that have just happened fairly recently. And I think what I'm talking about or what I'm going to talk about are some of the things that we in Hitachi are working on that can possibly help make the world safer place as much as possible. So I won't talk a lot about Hitachi itself. If you have been here yesterday, I think one of my colleagues would possibly have covered a lot about what Hitachi does. But essentially, we are a company that's over 100 years old. The engineering side of Hitachi has been doing a lot of work, building machines in the industry side to, many of you may not know this, but about 70% of parts in a car, especially the sensors in a car, are actually built by Hitachi. And of course, in recent times, over the past 50 years, we have been operating on the technology side. So when we look at the combination of operational technology and the information technology, we feel that Hitachi is very well poised to, operate in a world where combining the insights that you're getting out of operational technologies along with our skills in the information technology, I think we had actionable insights as somebody's, bottom line here. That's what we can get as an outcome. Anyway, I don't want to dwell a lot about Hitachi and talk about what we are doing, but if you see, I think Karuna was here yesterday as part of a keynote speech. Today, we have almost 55% of the world's population living in urban areas. That number is expected to go to about 60% by the year 2030 and closer to 75% by the year 2050. That means 75% of the world's population is going to be living in urban agglomerations. That's a fairly large number in terms of the population of the world. And therefore, we need to build what we are calling as the smart cities, cities of the future. So when you have something like that, and when you look at things that are happening in the world, in an increasing, fear of violent attacks, terrorism incidents that are taking place across the world, there's a need to also have safer cities for people to live in. In addition, there are also a lot of complications. I remember the time when I used to study in the University of Hyderabad here, and the road from the Gachibowli to Mehdipatnam, we used to be scared to travel at night. After 7 p.m., there actually used to be people who used to point a knife at us and take away our purses. But look at how much the entire landscape here has changed in the past about 20, 25 years. And while it has grown, it has also brought along with it a lot of issues, right from parking, right from traffic, okay? The kind of issues that we are facing when it rains 6 centimeters in about an hour's time. Those are all the kind of issues that we are going to be challenged with in the smarter cities. I'm of course not going to focus on everything, but I'll try to restrict myself to the public safety aspects of what smart cities can achieve. So the focus is to try and keep citizens and their properties safe. The key thing is be aware situationally what is happening around you. Okay? You have a lot of sensors today that are available that can provide an alert. For example, in the US, in some cities, we have deployed sensors which can detect gunshots. In the case of the Las Vegas incident, it took them 11 minutes to detect where the gunshot is coming from and try to, pinpoint saying that, hey, there are actually 3 hotels for those who have been, or 2 hotels that, if you have been to Las Vegas, there's this Mandalay Bay and then there is a Luxor hotel close by. So they couldn't figure out where these shots were coming from. But if we had gunshot sensors deployed in and around that area, using triangulation, we could have pinpointed fairly accurately. Maybe, instead of 32nd floor, we could have said between the 30th floor to the 35th floor is where these gunshots are coming from within a minute. It took them 12 minutes, and that caused a lot of deaths. In fact, it's coincidental that there happened to be a fire alarm somewhere in the same floor, and maybe that caused a lower number of deaths. But with sensors, you will be able to get automated alerts about events that are happening. Also, we can use some of these solutions for enhancing the experience of citizens across the city, whether it is in terms of traffic alerts, making sure that people are able to travel through public transport in a much more safer and efficient manner. Okay. Finally, of course, to also improve the overall operations, reduce the carbon footprint. Spending time sitting around in vehicles emitting carbon dioxide is not good for the earth as a whole. So, a lot of things can be achieved by smart cities. What are we doing from Hitachi? And I promise you this will be the last slide about Hitachi. I will try to talk a lot more about actual technology and how it is being deployed. So we deploy smart cameras, sensors, a lot of gateways which are connected, the smart lighting, parking, license plate recognition, traffic monitoring. A lot of these systems are available. Works on the Hitachi video management platform, either on a public cloud or a private cloud. There's a social intelligence analyzer which looks at Twitter feeds, Instagram, Facebook, posts that are coming in from a certain area, and based on that try to come up with any kind of alerts that can be useful to law enforcement. And of course, based on our own software called Visualization Suite, where all of this information is taken together and shown on a single pane of glass, as we call it. Okay, so I'm going to focus on one aspect of the entire thing that we talked about, which is video analytics. Hitachi Video Analytics has 3 broad areas. One is operational intelligence. Operational intelligence is doing basic things, using video cameras to do things like how many people are passing through a certain place. Are there crowds that are getting formed? Are there queues getting formed? Using parking space much more efficiently, recognize where parking is available. So operational stuff like that. And then you have security intelligence. Use face detection. Match faces. If you've got a record of criminals, if you've got a record of pickpocketers and so on, use that as a database and try to match faces of people in the crowd. Try to use object detectors. If somebody has left an object that is not supposed to be present at a certain place, ability to trigger an alert based on object recognition. And privacy protection, of course. You don't want, as you're moving around, you don't want every movement of yours to be captured somewhere, right? So there is a lot of privacy protection elements also that are built in into these solutions. Okay. So one of our implementations, as an example, if you see, the moment there is an alert about a suspicious object being left at a particular place, the video feed corresponding to that is automatically pulled up. From there, a suspect is identified. It is pushed back into the system to try and match. The suspect is located, and the track as to where the person has been moving is automatically captured. You also get similar face search to try and see whether there have been other areas where the same person has been located. If from the video you are able to figure out the license plate, take the license plate number, locate the getaway vehicle, you can also locate other suspects using live face matching, and then quickly take action on events that are happening. Okay. So as an example, here is intrusion detection. The moment somebody walked into an area where they are not supposed to be, there is a cooling off time period, and then the system will automatically throw an alert saying that, in this zone there is somebody who is not supposed to be present, and the moment they come into that zone, there is a alert that is triggered by the software. Okay. Similarly, if there are objects that are left behind at a particular place, and that's an object that should not be around there, an alert automatically is triggered off from that place saying that, hey, this is something that was not supposed to be present and is now possibly a danger. So you could, go pick it up, or you could locate the video feed corresponding to that, look at the person, maybe even try to see if you can locate where that person is currently. You can also analyze traffic. Okay. You can count the number of vehicles passing through a certain area. Of course, you can do license plate recognition along with that, but then it will also help you in looking at traffic patterns, routing, people across certain areas where there is heavy traffic or lower traffic or less traffic. You can also recognize types of vehicles. So the coloring that you see there is depending on the type of vehicle. It's able to pinpoint and recognize different types of vehicles. So this will provide urban transportation planners with enough data and information for them to make sure that citizens enjoy a much better quality of living in our urban cities. Parking challenges, this is one other area where there is parking available, but if you're not able to figure out where it is available. But in a system like this, you will be able to, notify people that there is availability of parking space, and there is, parking spaces that have been occupied. You'll also be able to look at how long people are parking at a certain area. You can measure the duration. You can also enforce, saying that if somebody is not supposed to park more than 10 minutes or 15 minutes in a certain area, automatically recognize their number plate and then trigger a alert or a ticket to them on this. So you can design your parking policies also based on data that you are getting from the system. You can also improve overall business and city intelligence. For example, you can count how many people are moving in certain directions. You can also track which are the the hot areas. For example, in a mall, you will know where the traffic pattern is flowing, and accordingly you could also devise systems whereby your HVAC systems are designed so that air conditioning is controlled, your energy and lighting is controlled to those areas where there is maximum people traffic, and accordingly save energy also in those buildings. You can also use it for direction control of people and vehicles. Which way are people moving? when they exit a train or when they are, you know, leaving a theater or a office, what is the pattern in which people actually move, and use those patterns to detect and figure out, what is the, for example, in this you could get a real-time count of the number of people actually traveling through a, metro, and accordingly plan for saying that, hey, there is a lot of people coming in towards Miapur depot, and therefore the number of buses that you would need to deploy to pick up those people off Miapur depot to take them to the surrounding or the neighborhood areas could be done in a much more real-time fashion. You can also improve the overall passenger experience. When somebody comes into the airport or into any place where there requires to be queuing up, the system can detect queues that are being formed, notify if additional counters need to be opened for taking care of people, and it also detects large crowds. Again, in an Indian context, this could be useful where you have things like dharnas happening, or where people queue up for buying tickets and there's likelihood of issues happening. So those are some of the areas where you could use the system for getting better customer satisfaction. And of course, like I mentioned, you can also put in a privacy detection module on top there, whereby, for example, hospitals, you do not want people to know who is walking in and out of hospitals, but you may still want to know details like how many people are actually going into a hospital or coming out of a hospital. So you will be able to apply a privacy detection module on top of all your video feeds. So why is Hitachi's video analytics better than other video platforms? One is, most video analytics today use pixel-based analysis, whereas we used vector-based and object-based analysis, and that improves the object recognition in a much better way. We also have a lot of machine learning behind the code, and that reduces the number of false positives, because we also use scenario-based code. For example, if you have object detection system and you have a mouse, okay, or a small rabbit coming in, standing in that place, you do not want the system to trigger an alert saying that, hey, this is a object. So the underlying machine learning algorithms figure out that it's an object versus a animal that will allow you to ensure that you are able to get much better quality of data. So finally, complexity is growing rapidly across cities, across organizations. You have smart lighting, you have computer-aided dispatch, body-worn cameras, you have facial recognition, gunshot detection, smart parking, drones. Drone detection is a new module that we have added. Right now, the biggest problem for the US law enforcement is drones, especially where they have events happening in stadiums. This is their biggest cause of concern. So our software now has the ability to detect drones, and it has the capability to alert law enforcement agencies. In fact, it can jam the signals to the drones whenever it detects an unauthorized drone flying around in the area. So there are a lot of challenges in smart cities, but with software, we hope that we'll be able to tackle a lot of this, especially with video analytics that can help tackle a number of different things. My actual presentation is much more, but in the interest of time, I would like to stop here and maybe let the audience have any questions if they have.
Hi. I have this question about public safety, especially in countries like India.
Yeah.
So far the object detection have been associated with a single object or a type of an object.
Correct.
But not with the relation of the objects of two or more objects with respect to a certain situation. So where I'm coming from is, how far are we from the time where cameras could detect something like a murder attempt or a rape attempt or a child molestation?
I don't think cameras today are at a stage where emotional, feedback is something that can be captured by cameras. Cameras and analytics on cameras still happens around inanimate objects or, things that do not have emotions connected to them. What it can possibly do is, based on social intelligence, if you can connect in the social intelligence system, if you are able to analyze social intelligence feeds that are coming in, if you are able to analyze patterns of movement of people. For example, for one of the US arms repository, what we have done is we have been tracking people or employee movement in and out of the office. And over a period of time, you get a pattern. Some people come in only at around 11 a.m. and work till 8 p.m. and then go out. And then whenever you have deviations in those patterns, somebody came in, that person who usually comes in at around 11 came in at 6. Is it a one-off, or is there some other issue behind it? And they were at a area where they were not supposed to be in. So these kind of elements will possibly help, but ability to attempt or to predict a murderer or a rapist is, I think, right now not in the realm of camera analytics, video analytics.
Okay, though the camera sees the interaction between what is happening, I mean, can it not figure out that there's an anomaly detection is one of the principles? So can we use anomaly detection for things like that?
It can, in the sense that if an event is happening in front of the camera, yes, it will be able to detect, for example, if there is a sword that has been taken out, or if there is a gun that has been taken out. It can detect the gun, it can detect the sword, it can detect those objects, and it can trigger an alert. Okay. That part of it is possible. What is the intent of it? Is it to fire a couple of rounds like they do in Punjab whenever there is a marriage, or is it to aim and kill a person? That is something that the software may not be able to. Of course, over a period of time, I expect that also. Where is the camera located? Is it located in Punjab? Then maybe, yeah, it is safe. Is it in Gachibowli? Then maybe it's a dangerous thing. That could be machine learning that would happen over a period of time.
You said that you are using object-based rather than compared to the pixel-based, right?
Right.
In the technology. Is it like open source, or suppose some other competitor want to follow the same based on the object-based? Is it not possible? Is it like a patented technology that you are using?
It is right now patented in terms of the technology itself, object-based. The vectors that are used are patented. Hopefully, over a period of time, we'll make it open source, especially in interest of public safety. What we would like to do is build a platform so that others can take. There might be hundreds of things that we cannot imagine today are what are possibilities. So over a period of time, I expect it to become much more open source. But right now, yes, it is not open source.
Can you please elaborate on the scenario-based code?
Sorry?
You said scenario-based coding, right? Scenario-based coding.
Correct, scenario-based coding. So in scenario-based coding, it is not just you're recognizing an object, but like we talked about a little while ago, it could be correlate different sequence of events that are happening. And then based on that, you say, hey, this is alert that is coming in. Not just based on individual frame of video that you are looking at. Or a sequence, there's a temporal time, time-based sequence that is attached to it, and based on that, the scenario, in the sense that where is the camera located, what time of the day is it, okay, all of those will come into factors when you are evaluating whether you should give an alert or not.
This is Sunil Desai from Moschip Semiconductor. I want to understand what do you mean by privacy protection, if you can elaborate a bit.
Sure. Especially, not, of course, not just in the Western world, but also in India. You do not want privacy to be, your privacy to be violated. So, we do not want people to know where you are going in, where you are coming in. We don't want everything to be recorded. Especially there could be sensitive situations like if you are going into a hospital. Okay, maybe you do not want that you visited a hospital to be made available to a insurance company. Okay, so what we mean by privacy protection is that there is a mask on the face, okay, or on the entire body itself. We could trigger off a mask, so you will know that there is a person there, but you do not even know whether it's a male or a female. So that entire privacy of the person is protected. However, this can also be, this can be overridden by law enforcement. Okay, if law enforcement says, no, I want to see who that person is, then yes, we would have to open it up. In this particular case, it's a fine balance of where you want to protect versus is it a criminal or whether it's a good person is something that you are not aware of. So there is debate that happens about where you should draw the line.